Hi, this is problem 18 of the AMC 12A. The zeros of the function fx equals x squared minus ax plus 2a are integers. What is the sum of the possible values of a? So there are two good ways to go about this type of problem. One is to just try to plug this into the quadratic equation and see if we can learn something useful. And in this case, we can. So let's use the quadratic equation to solve for the two zeros in terms of the coefficients 1, minus a, and the last is plus 2a. So plugging these coefficients into the quadratic equation, we found that the roots are equal to a plus or minus a squared minus 4 times 2a over 2. And so the critical point here is that in order for these roots to be integers, the term inside the square root has to be a perfect square. And that's how we can learn a little more about this particular type of integer equation. So let's pull out the term inside the square root. That's a squared minus 8a. So that's pull out the a times a minus 8. So we have two factors taken together form a square, and that's one that we can sort of look at and try to figure out what values of a will produce a square. So one way to produce a square is to make this term 0, so that leads to a equal to either 0 or a equal to, say, 8. Another way to make this a square is to perhaps create a 1 and perhaps a 9. That would be a perfect square. So let's see, that would be a is equal to 9. So 9 minus 8 times 9, that works. And there should be a similar solution where we make this 9 and this something like a 1. So let's make a equal to minus 1. So minus 1 minus 8, that's a minus 9 times a minus 1. That works as well. So a equals minus 1. Now for this type of equation, it turns out that you can't go to arbitrarily large values of a and still make this a square. And that seems to be a general principle for these types of quadratic equations. So in this case, we kind of run out of solutions with these four. The next method, we'll see this a little more rigorously, but I don't think you can find another solution for this. And at some point, you have to give up trying. And let's just conclude that the total number of solutions are given by these four values of a, and the sum is then 16 for choice C. Now, a more systematic way to do this is to use the Vieta formulas to find a relationship between the roots of the equation and the coefficients here. So in this case, we can determine that if our roots are, say, r and s, the roots of the equation, the zeros, then the sum of the roots is given by a. So we know that r plus s is equal to a. And we also know that the product of the roots is equal to 2a. So we know that rs is equal to 2a. And from here, we can eliminate a. We can take 2 times this equation and subtract it from 1 times this equation, and the a's will cancel, and that will give us rs minus 2r minus 2s is equal to 0. And this is one of the integer equation forms that you need to identify very quickly. This is, again, the most common integer equation form on the AMC. And the method of solution there is to identify the coefficients r and s, minus 2, multiply them together, add them to both sides of the equation. We can then factor the left side into a very useful form of r minus 2, s minus 2 equals 4. And we can take all possible factor pairs for 4 as being 1 times 4, 2 times 2, 4 times 1. And we also have to consider negative numbers as well. Minus 4 times minus 1, minus 2 times minus 2, minus 1 times minus 4. And now we have to basically go down and try to address each of these factor pairs and try to figure out what our values of r and s are. So let's go ahead and do that. So let's try to figure out what r and s are for the first case, 1 and 4. So that would make r equal to 3, s would equal to 6, and that from this equation would indicate that a is equal to the sum 3 plus 6, 9. So that checks with this. That's a good result. Let's go to 2 and 2. So that would make R is equal to 4, S is equal to 4, A is equal to the sum, 4 plus 4, A is equal to 8. 4 and 1, that would just swap the values for R and S. The sum would be the same. So this one basically generates the same solution as the first one. Let's go to minus 1 and minus 4. That would be R is equal to 1. S would be equal to minus 2. And the sum is equal to A, and that's equal to minus 1. And minus 2 and minus 2, we have R is equal to 0. S is equal to 0, the sum is equal to A is equal to 0. And the last case, minus 1 and minus 4, again, that just swaps the values of R and S, and the sum, R plus S, is unchanged. That's still equal to the same as before. So this exhausts all possible solutions for the second solution method. And again, we can take our sum of A values equals 16, and again, that's choice C. So again, these are two methods of solution, both of which are pretty handy to have in your back pocket. Thanks. Bye.